Hey, 8th graders, welcome to today's Explainer. We're jumping right into how to solve equations with multiplication and division. Our target today is clear. We're going to use inverse multiplication or division to solve equations, preserve equality, and then verify those answers by substitution. Let's get right to it. To get our minds in the right place, imagine a perfectly balanced scale just sitting there on a table in front of you. What actually happens if you change the weight on just one side? Well, it tips, right? It totally loses its balance. Honestly, this is the absolute core logic of algebra. You see, an equation is exactly like that perfectly balanced scale, and our main goal as mathematicians is to figure out the value of an unknown variable without ever letting that scale tip over. And that brings us to what we like to call the golden rule of equations. Now, officially, these are known as the division and multiplication properties of equality, but honestly, it all just boils down to fairness. Whatever mathematical operation you perform on one side of an equation, you literally must perform in the exact same way to the other side to maintain your balance. If you multiply the left side, you got to multiply the right. If you divide the right, you divide the left. It is an absolutely unbreakable rule.
Now, watch your step here, because there's a huge misconception trapdoor that catches a lot of students. Check out the incorrect method on the left side. When we see an equation with 4x, our brain sometimes instantly goes, oh, I want the x by itself, so I'll just subtract 4. But hold on. Remember, 4x means the 4 and the x are literally pushed together and multiplied. You absolutely cannot just subtract 4 from 4x to get x. Instead, look at the correct method on the right. To undo that multiplication, we actually have to use the inverse operation, which in this case is dividing by 4.
Let's see how this actually builds mathematically. In step 1, we start with our equation, 4x equals 28. Now, to isolate our variable, we apply that inverse operation to both sides. So, 4x divided by 4 equals 28 divided by 4. Then, x equals 7. See how we preserved equality there? We did the exact same division on both the left and the right sides, so the balance is perfectly maintained.
Okay, let's shift gears for a second and look at solving with multiplication. Over in step 1, we've got a new equation, y divided by 3 equals 6. Now, because our variable y is being divided by 3, the inverse operation we need to use this time is multiplication. To isolate y and preserve our equality, we're going to multiply both sides by 3. 3 times the quantity y divided by 3 equals 3 times 6. Then, y equals 18. By doing the exact same multiplication on both sides, we isolated the variable flawlessly.
You know, the best part of algebra is knowing for an absolute fact that your answer is right. Seriously, you never have to guess. We use an awesome little method called substitution verification. First off, we just start with our original equation, y divided by 3 equals 6. Next, we take the answer we just found, which was 18, and we literally substitute it back into the equation in place of y. Then we just calculate 18 divided by 3. That reveals that 6 equals 6. And since both sides match perfectly, boom, the answer is verified.
Let's dive into a real-world scenario to make this super concrete. Picture this. You're at the store buying 5 items, and your total bill comes out to $15. We can write this totally normal everyday scenario as an algebra equation. 5c equals 15, where c represents the cost of one single item. Now, because it's 5 multiplied by c, our inverse operation is to divide both sides by 5. So $15 divided by 5 gives us a solution of c equals $3 per item. Being aware of our units here, dollars and items, really helps us see how algebra is constantly working in the background of our everyday lives.
All right, 8th graders, it's time for a quick pause and check. I want you to actively engage with what we've been doing. Grab some scratch paper and a pencil. Your challenge right now is to solve the equation 8x equals 72. Remember to use your inverse operation and, of course, preserve that equality. Go ahead, pause the explainer right now and solve it.
Welcome back. Let's review the step-by-step logic together. Because x is being multiplied by 8, you need to use the inverse operation of division to isolate that variable. We divide both sides by 8 to preserve the balance of our scale. So 8x divided by 8 equals 72 divided by 8, resulting in x equals 9. If you got 9, awesome work applying that golden rule.
Let's do a second pause and check, just to really cement this skill. This time around, your equation involves division. I want you to solve the equation z divided by 5 equals 10. Once again, pause the explainer right now, use your inverse operations, and find the value of z. Okay, let's break down the reasoning for this second answer. Your variable z was being divided by 5, which means our inverse operation has to be multiplication. To keep both sides perfectly equal, we multiply both sides by 5. 5 times the quantity z divided by 5 equals 5 times 10, resulting in z equals 50. Look at that. You are officially isolating variables like a total pro.
First, always use inverse multiplication or division to isolate your variable. Second, strictly preserve equality by performing the exact same operation on both sides of the equation. Third, make sure to verify your final answer by using substitution.
Before we officially wrap up, I want to leave you with one final thought, a real-world transfer question to get you thinking. Imagine you're baking, and a recipe calls for x cups of flour divided by 2 to make just half a batch, giving us the equation x divided by 2 equals 4. How many cups of flour are actually in a full batch, and exactly how would you mathematically prove it? Take a second to apply your new skills, think about your inverse operations, and always remember to check your work. Thanks so much for joining me today to master these equations and keep on learning.